Good afternoon everyone. I am Jeewan. Currently I am pursuing BTech degree in electrical engineering from NIT Agartala and I am from Hyderabad. Today I am going to discuss rotational motion. So far you have learned translation motion. Translation motion means simply a body moves in a straight line or in a curvilinear path. So rotational motion. Rotational motion means in which a body turns about an axis. In our day-to-day life, we see many examples of rotational motion. For example, consider the door of your room. When you open the door, the vertical line passing through the hinge is the axis of rotation, and each and every point of the door moves in a circular path, whose centers all lie on the straight line passing through the hinge. And consider the ceiling fan in your room. Each and every point of when you switch on the fan, each and every point of the fan moves in a circular path, and the centers of all the circles lie on a straight line passing through the center of the fan. And consider the motion of the earth. The earth rotates, it's around the axis which is vertical and it's passing through the center of the earth. Consider the motion of the earth. Earth is rotating, because of which we are having days and nights. Consider if we don't have, if the earth is not rotating, then only one part of the world will be having the sunlight and other would be in the dark. So rotation is important in our day-to-day life and it is important, very important. So what is the definition of the rotational motion? Consider the rigid body, and if you take each and every point on the rigid body it should move in a circular motion, and all the circular parts should have its centers on a fixed line, and the planes of the circles should be perpendicular to the axis of rotation. And this straight line is known as the axis of rotation. And what is said to be the rotational motion? In translation motion, we have studied first kinematics and then the dynamics. Similarly, we will study first kinematics in rotational motion and then the dynamics. So first we will study kinematics of a rotational motion. To study kinematics of a rotational motion, consider a body moving in a rotational motion. For example, take a body whose axis may be vertical line passing through some part of the body, and let us call this the z axis, and take any point P on the body. At time t is equal to 0, the point is at position P0, and draw a line perpendicular to the axis of rotation from the point. Let it be Q. And after time t, the point has moved through an angle theta and it has attained a new position, that is P. So the angle of rotation is theta, which means we can say that the whole body has moved through an angle theta. So if the point P moves through a complete circle, then we say that the point has turned through an angle 2 pi radians, because 2 pi radians is equal to 360 degrees. So we measure the rotational motion of a body in terms of angle through which it rotates from its initial position. So we call that the angular position, difference in angular position as the angular displacement, that is denoted by theta. It is analogous to the term of translation motion, which is the displacement s. So suppose the point is at position p0 at initial time t is equal to 0, and after that time delta t, it has attained a new position p, and the change in angle, let it be the delta theta. So the uniform angular velocity over a period delta t, the angular velocity is denoted by the term omega. The uniform angular velocity over the duration delta t can be written as omega is equal to delta theta by delta t. If we want to find out the instantaneous angular velocity, then the delta t should be very small. So instantaneous angular velocity can be found out by omega is equal to d theta by dt. Next, if we If your body rotates through equal angles in equal intervals of time, then the body is said to be in uniform angular velocity. For example, consider the fan. When it has attained full speed, it will cover equal angles in equal intervals of time. Then it is said to be in uniform angular velocity. And the earth is said to have the uniform angular velocity. But if the angular velocity of the rigid body increases constantly or decreases constantly, then it is said to have an angular acceleration. For example, consider the ceiling fan. When you switch on the fan, the angle through which it rotates in the first second is small, and the angle through which it rotates in the second and the third second, it goes on increasing, and it finally attains a maximum velocity. So in the initial period, it is having an angular acceleration, and if you switch on the fan, and when you switch on the fan, the angular velocity slowly decreases, and finally it comes to the rest position. So it is said to have an angular deceleration. So angular acceleration or deceleration is denoted by the term alpha. So we are saying that angular velocity, angular displacement, and angular acceleration, which means they are vector quantities and they should have a particular direction because they are vector quantities. So what is the direction of these vector quantities? For example, if you consider this only, it is said to some anti-clockwise direction. We can find out the direction of angular velocity or angular acceleration or angular displacement varying through using the right hand thumb rule. Right hand thumb rule is very simple. Nothing but we have to curl your fingers in the direction of rotation of the body, and when you curl your fingers in the direction of rotation of the body, the direction in which your right thumb points out is the direction of angular velocity or angular acceleration or angular displacement. So for suppose if you consider this body, it is rotating in anti-clockwise direction. Curl your fingers in anti-clockwise direction. The direction shown by the thumb is towards you. So this is the direction of angular velocity. For suppose if the body rotates in clockwise direction, curl your fingers in the clockwise direction. The right hand thumb is showing in the direction away from you. This is the direction of angular velocity. So simple. The direction of angular velocity or angular acceleration can be found out by using the thumb rule, which is simple. You can curl your fingers in the direction of rotation. So I have been saying the rotational motion is similar to the terms used in rotational motion is similar to that of translational motion. The analogous terms are for displacement S, the analogous term is theta. For velocity, the analogous term is angular velocity omega. And for acceleration, the analogous term is alpha, angular acceleration. Consider a body initially at angular velocity omega naught, and it has attained a angular velocity omega in time t, and during the time t, it has covered an angular displacement of theta. You have studied in translation motion that the equations of motion for a body moving in translation motion are d is equal to u plus at, s is equal to ut plus of at square, and d square minus u square is equal to 2as. So we substitute these analogous terms in these equations and we find out the equations of motion for rotational motion, which is simple. For E is equal to u plus at, omega is equal to omega naught plus alpha t, and for s is equal to u plus of at square, theta is equal to omega naught t plus alpha t square. For v square minus m square is equal to s, omega square minus omega naught square is equal to 2 alpha theta. So these are the equations of motion for a body rotating or having a rotational motion. Next, if you consider any axis of rotation, then we can have if you look through an axis of rotation, we can say that the body may have two directions, that is anti-clockwise direction or clockwise direction. So we have to find we have to know which direction is positive or which direction is negative. That is up to your convenience. We can take any direction as positive, but once you take one direction as positive, then you have to stick to that, and you should not change your decision. Thank you.